Hello, this is session number 25, page 440 and 467. We'll continue with our TRIG situation. And you may need your two situations here again. Probably your TRIG foundational data. I'm not sure whether we'll need the log tables too much. I think we're talking about exact situations here. In any event, you might have both those available. I have a few on the board already. Save a little bit of time here. These are some of the rules that we could consider. I tend to just go ahead and make the picture and deal with it without those, but if you want to use those might save a bit of time, but I don't know how useful they really are overall. We're looking at the cos of 7/6 pi, and we'd like to go ahead and say, well, that's 1 1/6, isn't it? Divide 6 into 7, 1 1/6 pi. That means we're going 1 pi, which is 180 degrees, and then 1/6 more in here. So our reference angle is pi over 6. And then if you'd like to change pi over 6 to 180 over 6, 180 degrees for every pi radians, if you recall. We're talking 30 degrees. And then from your table, if you look for, in fact, the table right here in the front of the TRIG foundational data, the 30 degrees here, it looks like the cos of 30 degrees is 1/2 radical 3, or radical 3 over 2. And then don't forget the SIGN, okay? I'll put that in again just to be certain. Remember, it's STC, maybe in green, STC here, and STC. So that in the third quadrant where we're looking, the cosine is negative, so we should have a negative radical 3 over 2. Okay, that's number 3. Number 4, I'm not going to do, but going to ask you to look at these in 7 and 8 the same way. We've already done 7/6 over 5, so it's the same thing. It's 30 degrees, not going to change, right? And again, we're in this quadrant because we're talking about 7 over 6 pi. We're in the third quadrant where the sign is again negative. So again, no reason to go through the whole thing. We've done it already. Just change the 30 degrees here. And look at your table. I think you'll find the sign of 30 degrees is 1/2 radical 1. And you don't need the radical 1, of course. Just 1/2 or 0.5. Negative 1/2 or negative 0.5. That should be a good answer for us, okay? And number 7. Number 7 is 7 pi over 4. Trying to use the radian measure here, and you can, again, transfer to degrees if you want. I can kind of tend to wait till the last to do that. If you divide 4 into 7, it's 1 3/4, I think. 1 3/4 pi? 1 pi is 1 complete rotation. 3/4 pi looks like it's into the fourth quadrant, leaving us with 1/4 more. Agreed? Because we're going, the entire rotation is 2 pi. So if we've gone 1 3/4, 1/4 more would complete our 2 pi rotation. So we're talking about the reference angle here being pi over 4. Reference angle pi over 4 means that the tan of 7 pi over 4 is the same as the tan of pi over 4. But of course we have to adjust for the SIGN. And looking back here again, in the fourth quadrant tan is negative. So we're going to put a negative out front there or a negative at the end, either way. 180 divided by 4 is 45 degrees. And again, I think that this little table here on the right is very instructive. 45 degrees is 1 for us there. So we have negative 1 for our answer for number 7. Number 8 I chose to look at also because obviously it's the same as the 3 and 4 back here. The rotation is the same, 7 pi over 4. We're talking about the fourth quadrant again. We're just talking about the cotan. And you should understand the cotan is the reciprocal of the tan. So if the tan is negative 1, turn that upside down, and it's the same thing, isn't it? Negative 1 also for the cotan. So 8, very similar, in fact, to number 7. For number 18, different because it involves a 6 here instead of a 4, but in addition to that, it's also a negative rotation, okay? So it's negative 1 1/6 there, 7 over 6, 1 1/6 pi, negative rotation. Here's a negative pi, and then 1/6 more would make negative 7 over 6. So we're talking a reference angle of 1/6 pi, pi over 6. And that again, 180 divided by 6, 30 degrees. And with your table again, really nice. It doesn't require much, but it's a nice little handy table for us. How about 1/2 on that, okay? And then number 19 is the negative rotation also, but it's 3/4 pi. So our 3/4 pi is here. And we need 1/4 more to complete for our reference angle from the terminal side to the nearer x-axis. That'd be 1/4 pi over pi over 4. And we're talking again in the third quadrant, looking way back to number 3 back there. In the third quadrant, cos is negative. So assign a minus value there so you don't forget that. And then pi over 4, 45 degrees, just as it was back here in number 7. This time the cos of pi over 4 is not 1 as it was for the tan, but 1/2 radical 2 if you would, or radical 2 over 2, okay? So negative radical 2 over 2 or negative 1/2 radical 2 should be a good answer for us for number 19. We'll continue with a few others of these, and then we'll push on to the next page, 4, 6, 7, but there's still a bit more to do. After number 19 here, we're going to go on to number 27 next, okay? So I'll ask you to take a look at number 27 while I'm erasing this, and so you can use your time efficiently. I'll leave the rules there in case you want to use those. I'll probably just continue the same way I've been doing with this. By the way, these rules are also on that TRIG foundational data page, on the second page in fact, okay? I think we said 27 was next here. And 27 is the cos of negative pi over 4. I think a nice easy one for us here. And because of negative pi over 4, we're talking negative rotation, and pi over 4 here. So actually, the negative rotation gives us the same pi over 4 back here again in terms of the reference angle. And so we have cos of negative pi over 4 being the same as cos of pi over 4. And because we're in the fourth quadrant, again, I'll label that as STC, 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 ST, and C. The cos is positive in that quadrant, so we'll have a positive value there, cos of pi over 4. The cos of pi over 4 is 45 degrees, I think. 45 degrees, you might check that. And that, if I'm not mistaken, again from your table there, I think is 1/2 radical 2. Okay. I want to check that to see if that's okay. And that's a nice quick answer for number 27 for us. And number 30. Number 30 is the cos of negative 7 6 pi. And that's going to be our 1 1/6 rotation again. 1 1/6 here. 1 1/6. 7 over 6 in the negative direction. And that gives us a negative rotation, but we have the positive 1/6, if you would, or pi over 6 as the reference angle, isn't it? So really, the cos of negative 7 pi over 6 is the same numerical value as the cos of pi over 6. Cos of pi over 6, how about the cos of pi over 6 being a situation of 30 degrees, I think, isn't it? Cos of 30 degrees, it sounds like radical 3 over 2. You check that again on your table there, radical 3 over 2, or 1/2 radical 3, either way. And then let's again not forget that, and we talked about it back here, the sine tan cos, sine tan cos. So sine tan cos, sine is positive, cos is negative in that quadrant, okay? So assign that negative value, either initially or when we finish. Don't forget the SIGN, okay? So there's number 30 for us, negative radical 3 over 2. 36 brings us to something a little different, okay? Now 36, I'll show you how that differs for us. 36 is the cos of theta is equal to negative radical 3 over 2, okay? That's 36. I hope you see the difference between these. In this case, we're looking for, actually it could have been done this way, the cos of negative 7 6 pi is equal to x or equal to some number there. And we found what that number was equal to. Maybe right down here, cos of 7, negative 7 pi over 6 is equal to negative radical 3 over 2. That's basically what we're looking at for number 30. What we're doing now at number 36 is saying, look, I'm going to give you the answer here. Tell me what the theta was. Tell me what the number of degrees or the radian measure. In other words, the cos of what angle here has this for its function, negative radical 3 over 2. Well, you could consider, first of all, what we're talking about here, how many degrees is radical 3 over 2. Look at your table, and I think you'll find that radical 3 over 2 is for 30 degrees, isn't it? Radical 3 over 2, 30 degrees. Check back the cosine now of radical 3 over 2, looking at 30 degrees. So actually, we're talking 30 degrees here. This is 30, but it could be 30 degrees in any of these 4 quadrants, right? So we have to decide which of the 4 quadrants is at 30 degrees. So I'm looking at the table, finding that radical 3 over 2 is 30 degrees, but we're talking negative. So where is the cos negative? Sine tan cos, sine tan cos. Looks like the cos is positive in those two. How about the cos is negative? We're kind of eliminating here. The cos is negative right there. That be okay for us? I'm going to get rid of those two and say that the cos is negative in those two. I'll write it again, STC, 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 ST, and C. Cosine positive in these two. If we're talking negative cosine, it's in those 2 quadrants. Let's see what we're talking about here. In this quadrant, if this is 30 degrees, then how about the angle? The angle associated there. The angle should be 150, shouldn't it? 150 there? Then how about this one, if we're talking this one? That's the 180 degrees plus 30 more, isn't it? How about 210? 210 degrees? Okay, so those are the angles, 150 and 210, which should have negative radical 3 over 2 as our answer. We could also do it this way. 30 is pi over 6, I think. Pi over 6. And then how about this pi and one more? How about 1 and 1/6 pi right there, okay? I think that'll work for us. From here to here then, if this is 1/6 pi, the red arc here first would be 5/6, wouldn't it? 5/6 pi. A reference angle 5/6 pi and 1/6 more the complete rotation. So our angle there is 5/6. And then of course, we said that this was the entire pi and 1/6 more. So that'd be 7/6. Okay, so 150 degrees is the same as 5/6 pi. And 210 should be 7/6 pi. Okay, so those should be the answers we have then. We have 150 degrees at 5/6 pi and 210 at 7/6 pi. I'd ask you to get all 4 answers, okay? I think in the back of the book, the author only gives you 2, okay? This is even, so you won't see it for the even ones, but I think the odd one you'll find that to be the case. Give me all 4 if you would, because you never can tell which answer is going to, in the final, this will be multiple choice, and you don't know whether you have the radian measure as your answer or the degrees. So you should get both. In any event, after finding 150 degrees, if you wanted to, and you didn't know about what I'm saying here, you could always change 150 degrees to radians by saying what? That there are what? There are pi radians per 180 degrees, right? Do that. And then the zeros will go for you, and the degrees also. And 15 and 18, I'm thinking maybe that 3 goes into 15 5 times, and 3 goes into 18 6 times. Same answer, right? And you can do the same for 210 also. So there are a few ways of getting the answer, but don't stop at just 2 answers if you would, okay? Get all 4. It's much more complete that way, and it shows a better understanding, I think, of the entire situation. Okay, there's 36. We're going to try at least 1 more of these. In fact, maybe even 2. And then we'll get on to the next page, which is kind of nice. The next page is basically a page of graphs and pictures. So for those of you who like graphs and pictures, we'll be playing with that in just a minute. And unfortunately, I can't project here, as I would in class, the page there with the choices. It's a choice situation on page 440. So what I'll do is I'll go ahead and do it kind of the way I would normally do it anyhow, would be to make the picture myself based upon the data, and then to compare the picture that we make with the picture that is given by the author, okay? And we'll say, oh, the picture we get, okay, that looks very much like, and we'll find out whether it's A, B, C, or D from the author.